Chapter 2, Fundamental Data Types, Part 3. So, constants, as we mentioned earlier, can help your program be more descriptive, easier for other people to understand. So when we want to create a constant, that means we don't want it to change. We want to take some literal and we want to provide it a name so that it will be easier to figure out what's going on in the code. It doesn't mean that we want to be able to change that value. We just want it to be more descriptive. We use the keyword final. Final is a word that means something special to Java, and it means this is not going to be changed. So we say final, followed by the data type, in this case final double, and then we put the name all in caps. The all caps makes it easier for us to see, oh, this is a constant. And it's just a convention that all the programmers agree we're going to put constants in all caps. So then we provide it an initial value, as in equals 2, bottle volume equals 2. So look at which is clear. Double total volume equals bottles times 2, or double total volume equals bottles times bottle volume. Allegedly, the bottle volume would be more descriptive than the 2, because a programmer wouldn't understand what 2 means. So to declare a constant, again, we use the keyword final, followed by the data type, followed by the name in all caps, and then equals some value. As I mentioned earlier, it's customary but not required to use all uppercase. We're going to use all uppercase in this class because it's really important that we have good style. So even though Java would allow it if you didn't use uppercase, it will be something that you are graded on, whether or not your constants are all uppercase. Let's talk about comments. We've been talking about making your code more clear, such as in using constants. Another way that you can make your code more clear is to use comments. There are 3 different types of comments in Java. One, we've already talked about in Chapter 1. That's the single line comment, and it starts with a slash slash, that's on the same key as the question mark, and it ends at the end of the line. The second one is the multi-line comment, and it starts with slash star, followed by as many lines of comments as you want, and it ends with the star slash. That's a multi-line comment. And the final comment is a Java doc comment, and it starts with slash star star, following all the comments, and then star slash. In Computer Programming Essentials, when we're first learning how to program, we don't need to worry about the Java doc comments right now. But let's focus on the single line comment and the multi-line comment. Comments are used to make your program more clear to other programmers, to describe what's going on in your code. Comments will precede, come before, the lines of code that they are commenting. And the compiler completely ignores the comments. The comments do not affect the running of your code at all. It just makes it easier for another programmer to understand. Here are some examples. Look at the top of this code. It's using the Java doc comments. We could also just use a multi-line comment to say this program computes the volume in liters of a 6-pack of soda, blah, blah, blah. We are going to put multi-line comments at the top of all of our code to include your name, the date, a brief description of what the program does, much like the one you see here in the example, and then our test data, and I'll talk about the test data coming up. And then you've got your program, and notice next to some lines, such as at line 10, there's a single line comment saying liters in a 12-ounce can. That's where that 0.355 came from. And then at line 17, 2-liter bottle. That's our bottle volume equals 2, because there's 2 liters per bottle. So those are single line comments to clarify that line of code. We could also put those comments right on the line before that line of code, but we would never put them after. We would never put them on the line following the line of code that we're commenting. It's a common error is to forget to declare variables. So in the example here, liters per ounce is not declared when we're trying to use it. It's not declared until the next line. You have to declare variables before you use them. And the other common error is uninitialized variables. So if we say int bottles, and then we say int bottle volume equals bottles times 2, well, what value is in bottles? We don't have a value there, so that would also be an error. Another error is an overflow error. It means that the number we're trying to use is too large for the space that we've given to store it. Overflow error means that we've exceeded the amount of room that we've got to store a value. And we'll talk about that in just a second when we look at how large different variables are. Round off errors, this happens a lot when using double numbers, is because of the way that they're stored. We can frequently wind up with round off errors, and so we're going to learn how to format our output to help avoid these. Here are some data types that we're going to look at. Look at the first line, int. There are two values that you need to be aware of. Integer.min value, that's the smallest integer that we can store, and integer.max value, that's the largest number that we can store. So the smallest integer that we can store is about negative 2.147 billion with a B, and the largest number that we can store is 2.147 and so on billion. So would an int data type be appropriate if you wanted to store the population of the world? No, because the population of the world is about 7 billion. So you wouldn't be, it would be too big to store in an int. Other data types, byte, short, long, we are going to ignore those in this class. Let's take a look at double. A double is a double precision floating point type. That means that it can store 15 decimal digits with a range of about 10 to the negative, plus or minus 10 to the 308, so either negative or positive, but it depends on the number. So because doubles are stored differently from whole numbers, we can't be exactly precise about that. Float we're going to ignore in this class, and char is a single character, and we'll talk more about char in just a moment. So looking again at the range of values, let's focus on int. It can store a very large number, negative 2.1 billion to positive 2.1 billion. And then floating point numbers, we're only going to be looking at doubles in this class, and they are much more precise and used for heavy math. But because they are more precise and because memory right now is pretty cheap, people tend to rely on doubles. But if memory becomes an issue, or if you're dealing in an environment where you really have to be conservative with how much memory you're using, then we would rely on using a float. A Boolean data type is either a true or a false. It's just one of two states. You can think of a Boolean being like a light switch. Go to your nearest light switch, turn it off, turn it on. It only has two different states. A Boolean is the same. It's either true or it's false. That's it. It can't be maybe, it can't be 670, it's true or it's false. And a char, also called a char or a character, is one single character. In single quotes, that's how we know it's a single character. Here's another graphical example of how much space each one of those takes up in memory. Don't really need to be concerned with this. We'll be using int, double, Boolean, and char.